Topical screen design and single entity. The following of definition attribute in the local data model C1-3RH entity letter employment as a separated table when installed as a part of the physical database. When a table later used in production, when the value will be changed during processing data, maintenance is changed needed to keep each column and row value up to data required, create, read, update, and delete. CRUD, processing screen design for the CRUD, processing and delivery from definition, each entity and logical data model.
Figure 10.6 show the order entity data map which be attribute display in each entity. At the map left of figure, the cluster beside it at the top right of the figure, she has been delivered from this map using entity dependency analysis. The bottom left of show customer as a first menu item. The column screen design at the bottom right, she has been delivered from the local definition and entity customer. 10.4.7 Distributed Transaction Information Analysis Data Reflection. We can improve the unavailable network access transaction response time by using destructive database design and considerations. The only reason the access is the mode across network each access part 1 and 4 it's to obtain respectively job name and employee name. This column are well dependent on job name. Bear on job the employee number in employee. For the normalization to 3 BNF, we must leave both for these columns positioned to those tables. But what if also positioned them in job skill? An employee skill, this will be different but she must be in fact.
Typical screen design of one-to-many association. The top part of figure 10.7 show the data map that we developed in chapter 6. We can see that the access path along the one-to-many association from job to job skills has been highlighted. This suggests that the following access to a specific job, all of the job skills for that job can be displayed. Logical transactions performance analysis. For each job, first identify all the job skills required by that job for each of these skills. Next, identify each employee who has the relevant skills and determine each employee's name. The resolution of this query requires a number of logical accesses to the data map that is shown in figure 10.11. Each logical access will be calculated in the following pages of physical input-output accesses. For transactions performance analysis, when the data map model is later implemented as a physical database, this access to job is shown in the first detail row of table 10.1. It appears as entry job in the second column of the row under the heading access path. The third column of the row indicates that the type of access in the red are access. The fourth column is headed association frequency of occurrence and show the association frequency as 1. For access to a single job, the fifth column shows that this single job query requires number of logical references, also of number 1. The sixth column shows the total reference per hour to the data map is 5 and 6. Physical transactions performance analysis, not optimized. To calculate anticipated transactions, response time for each transactions performance analysis. We will discuss the performance impact of various physical database design strategies. We will first consider a database design where each logical data entity is implemented as a separate physical database table. Each logical reference will therefore require a physical input-output access to the relevant table. Physical transactions performance analysis, database clustering. Most DBMS product today enable a DBA to specify that child entities participating in one-to-many association be stored physically close to the parent's entity to minimize input-output access. Distributed database design not optimized. The datamap figure 10.9 that we have used for transactions performance analysis to this point has assumed that all tables are directly accessible locally in physical database implemented from the datamap.
So that you